Iran's Revolutionary Guard recently initiated a global crisis through an act of pure panic. By attempting to block a narrow waterway that handles 20% of the world's oil supply, they constructed a wall of explosives that they now lack the means to dismantle. This map shows the geography of the Strait of Hormuz. It is the most critical maritime choke point on the planet, serving as the sole exit for the Persian Gulf's massive oil exports. The crisis began in early 2026. IRGC teams frantically dumped thousands of mines overboard to block Western warships, but they failed to record GPS coordinates or lay the devices in any traceable pattern. They effectively locked the door and lost the blueprints. Natural conditions soon turned this tactical error into a catastrophe. The currents in the strait are brutal. If a mine snaps its mooring, it becomes a drifting explosive. For a massive supertanker on the horizon, the shipping lane has essentially become a game of Russian roulette. The IRGC attempted to extort a $2 million cryptocurrency toll for safe passage, but they can't actually deliver on the promise. Because they lost track of their own ordnance, they cannot guarantee that any vessel, including their own, can safely navigate the minefield. Traditional naval minesweeping relies on clearing fixed, predictable patterns. In this environment, every sweep is temporary, as a cleared path today could be occupied by a drifting mine tomorrow. This cycle makes standard clearance functionally impossible, shifting the objective toward neutralizing the mines before they ever hit the water. To maintain this threat, the Iranian Navy employs the Mosquito Fleet doctrine. They have pivoted away from large, easy-to-target destroyers in favor of hundreds of these small, cheap fiberglass speedboats. These boats rely on a terrifyingly simple stern drop method to deploy their cargo. Under the cover of darkness, a crew simply rolls heavy explosives off the back of the boat, while blending in with civilian traffic, fleeing to the safety of the coastline in seconds. The ordnance itself is diverse. The stockpile includes simple contact mines that float near the surface and explode on impact, as well as advanced bottom mines. These sink to the seafloor and wait to detonate the moment they detect the specific acoustic signature of a passing supertanker. These craft also utilize swarm tactics. By launching dozens of boats simultaneously from every direction, the IRGC aims to overwhelm automated defensive systems like the phalanx turret, presenting more targets than the software can physically track and engage at once. This combination of low-tech hardware and high-speed chaos is designed specifically to exploit the vulnerabilities of traditional deep-water navies. It requires a specialized defensive playbook to counter effectively. The first strategy is preemptive capability destruction. Since clearing mines under active enemy fire is a high-risk operation, the U.S. focused on destroying the vessels before they could deploy their cargo. Strategy 2 relied on an intelligence coup. By layering human intelligence with signals and maritime surveillance from aircraft like the RC-135, the U.S. pinpointed exactly which civilian fishing boats were secretly outfitted for military operations. Strategy 3 targeted these vessels while they were moored. Attacking a stationary ship at a dock is significantly more precise than hunting moving targets in the crowded shipping lanes of the strait, and it eliminates the risk of accidental international incidents. Strategy 4 utilized a dual-target doctrine. While drones struck the mine-laying boats, heavy strategic bombers destroyed the inland mine storage facilities. This ensured that even if replacement boats were available, there would be no ordnance left to arm them. This coordinated approach removed the conflict from the water entirely. It became a process of systematic logistical erasure. The precision instruments used to execute these strikes are the MQ-9 Reaper drone and the AGM-114 Hellfire missile. The engineering challenge here is truly extreme. Targeting systems must lock on to a tiny fiberglass target, making erratic maneuvers while traveling at speeds up to 69 miles per hour. The Hellfire tracks targets using laser guidance. As the drone follows, onboard sensors continuously calculate the boat's speed and direction, feeding real-time data to the missile. Traveling over Mach 1, internal guidance adjusts the flight path in milliseconds, anticipating maneuvers to strike the predicted location. Predictive algorithms have mathematically neutralized the advantage of speed. These boats can no longer outrun a weapon that calculates their future position before they even begin to turn. This technological gap resulted in a total collapse of Iranian maritime capabilities. In just 10 days, U.S. forces destroyed 16 mine-laying ships and over 60 warships and submarines. Historical precedent suggests that singular Iranian provocations lead to immediate, large-scale retaliation. This follows the pattern of previous conflicts, involving vessels like the Sahand, which were pummeled by missiles and heavy bombs, until their own munitions detonated and sank them. Modern naval doctrine secures choke points like the Strait of Hormuz through total asymmetric preemption. The U.S. uses technological overmatch to dismantle an enemy's infrastructure and equipment before a single mine can ever reach the water.